10.3, 10.4, Introduction to Polynomials. Polynomial just means more than one term. So let's look at the definition of term. Term is a number, a variable, or a number with a variable. 2 is a term. X is a term. 2x is a term. 3x squared y to the third is a term. Anything that's connected together with multiplication is a term. 2 is a constant term. It has no variables. It's always a 2. 77. Any number that stands alone. -6. Those are all examples of constant terms. A variable term is a term that has variables in it. So x, 2x, 3x squared, y cubed, those are all examples of variable terms. The reason why they're called variable terms, for example, the 2x will vary based on whatever x is. If x is 1, then that becomes 2 times 1, which is 2. If x is 2, it becomes 4. X is 3, it becomes 6, so on, so on, so on. So variable terms vary based on the x. They have a variable. The coefficient in front of the variable is, or the number in front of the variable is called the coefficient. If I ask you what's the coefficient of 2x, you would say 2. If I were to ask you what's the coefficient of 3x squared y cubed, you would say 3. If I ask you what's the coefficient of x, you would say 1. 2 is a coefficient of itself. I really don't want to say this, but I'm going to. 2 is the same thing as 2x to the 0 power, because x to the 0 power is 1, and 2 times 1 is 2. In case you wanted to know, that's what's going on. The degree of a term is either the exponent or the sum of the exponents on the variables. These are always on the variable. So if I ask you what's the degree of this term, you would say 1, because an x is the same as x to the first. The degree of 2x is 1 also, because we only look at the exponent on the variable. If I ask you the degree of this term, you would say 5. 2 plus 3 is 5. This is the only time you get to add exponents with different bases. It's just a definition. So let's do some more examples. Let's find the coefficient and degree of the following terms. Let's just consider 7x squared. On this one, the degree would be 7. And I'll take that back. The degree is 2. Don't let that confuse you. Degree is 2. I was thinking the coefficient. The coefficient is 7. It's the number in front. So the degree is the exponent. Coefficient is 7. Let's look at 8x squared y to the 6th z to the 3rd. The degree would be 2 plus 6 plus 3, which is 11, and the coefficient will be 8, number in front. Let's do one more. X. The degree is 1, and the coefficient is 1. And the reason why is x is the same thing as 1 x to the first power. Keep that in mind. Polynomials, once again, I've already mentioned this. They're a sum of terms. Always keep the sign of the term. Keep that in mind. The degree of the polynomial differs from the degree of the terms. What you want to do is find the degree of the polynomial. You will find the degree of each term, and then the term with the highest degree, well, that degree is the degree of the whole polynomial. We'll do some examples to explain that. Polynomials are always written in decreasing order by degrees or by exponents. And when it says evaluate, it just means substitute, and then use the order of operations to find the answer. And we simplify by combining like terms. If you don't understand like terms, I'm going to give you a detailed explanation of those. First example, expressed in correct order. As you can tell, they're not. If you look at the degrees, they're not in the correct order. We always start with the highest degree first, highest exponent, which is 6x cubed. In fact, if I were to ask you what are the degrees of these 4 terms, you would say 1, 3, 2. Some people may not know what this 8 is. We'll talk about that here in a second. We use this example to explain that. So you have 6x cubed, and then x squared is the next, but notice that there's a minus in front of it. Keep it. And then 3x, if you don't see a sign, it's always positive, and then the minus 8. Now if I write the degrees underneath here, we already said this is 3, 2, 1. It only makes sense that this is 0. Hence, that's why 2, a constant term, is same as a term with degree of 0. So, in other words, we don't write the variable in. And it says find the degree of this polynomial and determine if it's a monomial, binomial, trinomial, or none of these. Monomial just means one term. Binomial means two terms. Trinomial means three terms. Otherwise, it's none. Now, terms are separated by pluses and minuses, but the minus stays with the term. And so if you count 1, 2, 3, there are three terms, which makes it a trinomial. The degree of this term is 2. The degree of this one is 1. And the degree of this one is 0. You use the highest degree. So the degree of the polynomial, or the whole polynomial, don't add them. It's the same as the highest one. And that's it. Now let's do an evaluation problem. When it says to evaluate, all that means is you substitute. Then do the order of operations. When I do this, let me show you my little technique. And it very, very rarely, it would never go wrong. I rewrite the expression with the variables. I use empty parentheses. And then inside the parentheses, I place what the numbers represent, what the variables represent. X is -2, so that goes for the x. Y is a. And that's how I always do my substitutions. Unless there's too many parentheses roaming around, then I'll change it. By the order of operations, we do the exponent first. We can go ahead and multiply here if we want to. Let's just go to the side. I'm running out of paper. 2 times 4 is 8. 8 plus 24 is 32. Now, before I do the next series of notes, let's do this. Sometimes you're going to see a question where it wants you to rewrite this with the missing powers. And all that means is we're missing terms. See, normally you would expect to see an x squared, which this doesn't have one. 3, 2, 1, 0. So in order to put one in there, it's like decimals. What do we use for placeholders for decimals? 0. So if you see that, that's all that means to do. Now, let's talk about like terms. Like terms are terms with exactly the same variables and exponents on the variables. Constants are considered like terms to all other constants because they don't have exponents. They don't have variables. There's plain old numbers. So, like terms, exact same variables, exact same exponents. So let's do this question right quickly. Are the following like terms? These are yes or no questions. 2 and 3, are those like terms? Yes. They're both constants, plain old numbers. You can always add them and subtract them together. How about 2x and 4x? The answer is yes. They both have an x. That's all it means, an x is the first. How about 7 and y? The answer is no. One's a number, a constant, one's a variable. They're not alike. You can't add a number to a letter. You can't do that. Not like terms. Let's see, how about 7x and 6y? The answer is no. They have different variables. You know, they have variables, it's got to be the same variable. How about 8x squared and 9x squared? The answer is yes, they both have x squared. How about this one? 7xy and 10yx? Answer is yes. xy, yx, same thing. Same thing since 7 times 3 is equal to 3 times 7. Doesn't matter what order you multiply. That's the cumulative product multiplication. Does not make a difference. It's the same thing. So, let's do one more. How about 6x squared y cubed and 11x cubed y squared? Answer is no. That's got x squared. That's got x cubed. That's got y cubed. Y squared. They're not the same. If you were to write them out, that'd be xx, y. That'd be xxx, y. It's got to be the same number, same variables, and same number of variables. Okay, here we go. Now let's do combining like terms. This is where you keep the variable part and ends and subtract the coefficients. Let me do a quick example. Just give you an idea of what's going on, different way maybe to look at it, think about it. 2x plus 3x. Think of it as abbreviations. Making a grocery list. You're going to buy some xylophones. Xylophones begins with letter X. One store you're going to buy 2 xylophones. Another store you're going to buy 3 xylophones. How many xylophones total are you going to buy? You would say 5 xylophones. Instead of writing down xylophone, you might just use the letter X. 2x plus 3x is 5x. You want to see the real way to write it? 2 plus 3, keep the x. 2 plus 3 is 5, 5x. You can bypass that step. That's what you're doing now. Keep the variable, add, subtract the coefficients. In this case, add the 2 and 3 and keep the x. So here we go. Let's add the like terms here. I'm going to start with the x. There's the next term. There's the next term. I'm going to put those together just to show you what's going on. When we do that, we keep the x and do 4 minus 7 is negative 3. Let's mark those out. We're done using those. Here's a y term. There's another y term. So we have negative 3y plus 6y. When you add those together, when you combine them, you get plus 3y. Let's mark those out because we're done with those. Now we have a plus 8 and a minus 2. Plain old numbers. We always like plain old numbers. 8 minus 2 is 6. It's positive 6. Nothing left. No more like terms because they don't all have the same variables. You're done. That's all you're doing. Did you catch the mistake in the previous problem? Let's do it again. Let's take the 4x and the negative 7x. Let's put those together. Let's take the negative 3y and the plus 6y. Put those together. And the plus 8 and the plus 2. Did you find the mistake? Let's continue. We're going to combine like terms. Both of these have an x. Take 4 minus 7, which is negative 3. Both of these terms have a y. Negative 3 plus 6 is positive 3. And then plus 8 plus 2 is plus 10. And we're finished. Did you catch the mistake? It's an easy mistake to do is write the problem down incorrectly. If I can do it, you can do it. We all do it. Let's do this example down here right quickly. We'll come back to that one here in a minute. This one, they both have an x and a y squared. So we'll keep the xy squared and we'll just do the numbers in front. Negative 13 minus 3 is a negative 16. Done. Do not change the exponents when you add and subtract. Only when you multiply and divide can you change exponents. Never when you add and subtract. Alright, let's do this one now. By the order of operations, you want to do what's inside parentheses because they're not like terms, so we got to do multiplication. In this case, distribute property. So let's distribute to 3. 3 times 4x is 12x. 3 times 7 is a positive 21. Now when I distribute this to 8x, I don't see it as an 8x, I see it as a negative 8x. So let's take it as negative 8x times 2x is negative 16x squared. Negative 8x times 1 is negative 8x. Let's combine like terms. First off, this is the highest degree term. Let's write it first. These two both have an x. We're going to combine those. 12x minus 8x is 4x. In fact, it's a positive 4x. And this 21 is the only constant term, so let's write it down. And we're done. That's all you're doing. So let's do this last one, and let's skip all the steps. Let's go straight to the answer. This one and this one both have y squares. Add the numbers in front. Keep the variable as it is, y squared as it is, not y to the fourth, or y squared. And you're done with that. Let's take the plus 3y, and I think there's a minus y. Some people want to see it as a minus 1y, and that's fine. Plus 3 minus 1 is plus 2y. And then we have a minus 7 and a minus 10. Makes that a minus 17 when you combine those. Probably don't want to circle them like I did. It's really easy to confuse if they're positive or negatives. I'm still not for sure what I started with. But that's the idea of what's going on.